All right, we are live from Orem, Utah, Utah Valley University campus. Okay, here we are. We're going to start actually. So all of the stuff that we've been learning up to now is for this section, which is solving logarithmic and exponential equations. Okay, that's really what we're trying to do. Okay, so if I have 5 to the x equals 125, just think about how you would solve that. So, no, what do you think?
You're going to solve for x.
We would solve for x.
It's not wrong.
What goes into 125? How many times of 5?
Yeah, so we could rewrite 125 as 5 to some power, right?
Right.
5 to the what?
3.
5 times 5 is?
25.
25 times 5?
125.
125, so that would be 5 to the third. So now we can just x equal to 3, right? X equals 3. That make sense? Okay? Who needs a calculator? Okay? All right, how about this one? What if I had 5 to the 2x equals 5 to the x plus 1? Valencia, what must be your turn?
Oh, right.
What do you think in that case? We got the same base, right?
Yeah.
So if the bases are the same, what has to be equal?
Exponent.
The exponents, right?
Yep.
So we just have to set those equal to each other. So 2x equals x plus 1. How would you solve that?
Well, first I'll get the x's on the same side of the,
Okay?
so it would be.
So how to get rid of
subtract
that?
an x.
Subtract x. So x equals
1.
1. Okay? Now you know what's going to be funny is after this problem we're going to do a lot more complicated problems, and then I'm going to put the test question like this, and you're going to be like, oh, I'll solve that. So don't forget. Okay? These are easy. Okay? Now let's say that they don't have the same base, such as 3 to the x plus 2 equals 7. Patrick, how would you solve such an equation?
Well, I'm going to assume that you turn it into a log
Yeah, that's a good assumption. Why?
because they don't have the same base right now.
Because they don't have the same base. So essentially we're using the change of base formula, right?
Yeah.
You can use any base that you want. Okay, what base would you like to pick?
3.
3?
10.
You could pick 3, I don't think that's easier. 10 might be easier though. Why? Why would 10 be easier? Because you have it on your calculator, okay? That's exactly why. Okay, so if we take the log base 10 of both sides, what can I do with this?
Pull it out the
Pull
front.
it out front, okay? So this becomes x plus 2 log 3 equals log 7. Now we need to get the x all by itself. How do we do that?
Now I can divide by log 3.
Divide by log 3. Divide by log 3. So those cancel there, and I get
X plus 2
x plus
equals
2
log 7 over log 3.
log 7 over log 3. Can I cancel the logs? What do you think?
Don't you think so?
Don't think so. That's good, because some of you will, and I'll get mad at you. Okay? That's an operator. You can't cancel the logs. Okay? Can I write that as a single log?
Yes.
Yes.
No,
No, you solve what? It's a fine.
it's not the same.
What that equals.
Okay? This is not the same. This does not equal log of 7 over 3. It's not the same thing. in this case, I could do log 7 minus log 3. In this case, I just have to leave it. Okay, that's another common mistake. So don't do that. Okay, now what?
Minus 2 gets x by
Subtract
itself.
2. So we get x equals log 7 over log 3 minus 2, which I haven't decided if I should let you use calculators tomorrow. You could plug that in your calculator.
I'm not doing that.
Back in the old days, before we allowed you to use calculators, that was the correct answer. Okay? Now, if you did plug it in your calculator, you would get negative 0.2286, I think. 8756, sorry. Okay, that would be, okay. So this is what we would call the exact answer. This is the approximate answer. Okay, so if I ask you for an exact answer, this is what I'm looking for. If I ask you for an approximate answer, that's what I'm looking for. Because the approximate answer has even more decimals than I listed there, okay? So pay attention to the wording, exact, approximate, okay? All right, how about, let's do another one. Solve 8e to the 2x equals 20. Mauricio, it must be your turn. How would you solve this? I don't know. That might have been your correct answer, but it won't be my correct answer. Do we have any phone of friends who want to help them solve that? Glenn, do you want to help them solve that?
Would you just essentially do the same thing you did for the last equation, right, Joe?
We would, but that darn 8's in the way, right? Gotta get rid of that 8 first. So, Mauricio, how could I get rid of that 8?
I'm not quite sure. Can you pass it to the other side?
How do I pass it to the other side?
It's gonna be 20 over 8.
So yeah, you can divide both sides by 8, right? Okay, so this becomes e to the 2x equals 20 over 8, which is 10 over 4, which is 5 halves. Okay? Now what? We got different bases, right?
Yes.
And so because when we have different bases, we use the what he said. What did he just say?
I didn't hear.
The change of base formula, right?
Yeah.
We're using a change of base. What would be a really good base to pick?
10.
10? Not on this problem.
E.
E. Base E would be a very good base. Okay, so we're gonna do what?
So it's gonna be,
I think Eric whispered it, I heard it, but I don't know if you did.
no, I didn't. I wasn't paying attention.
Whisper a little louder, Eric.
Natural log.
Natural log, all right? We're gonna take the natural log because the natural log of E is 1. Okay, so we'll take the natural log on both sides. And then what can I do with the 2x?
Can you pull it to the,
Up front, right? So this becomes 2x equals the natural log of 5 halves, right?
yeah.
Okay? And then what?
Now you pass the 2 to the other side.
And how do I pass the 2 over?
It's gonna divide everything.
Divide by 2, right? Does that 2 cancel that 2?
No.
Good. Didn't fall into that trap. That was good. Okay? So, a couple of different answers. X equals the ln of 5 halves divided by 2. That could be one correct answer. Another correct answer could be ln of 5 minus the ln of 2 all over 2. Did you know those are the same answer? Okay? You could also plug it in your calculator, but these are exact answers. Your calculator is going to be what? An approximate answer. The approximate answer is 0.458. Okay, does that make sense? How many can't wait to do this homework tonight? How many can wait? All right.
I kind of did that homework already by mistake, so.
You already did it by
I
mistake?
could- Yeah, so I couldn't wait, sorry.
Okay, you couldn't wait. That's good. All right. I've only got a minute left, so I'm going to do a really hard one here. How about this? In fact, we're not going to finish this because, yeah. So we're only going to worry about the exponential part of these, so we won't worry about the logarithmic equations yet. But this is a really good one because it's really confusing. E to the 2x minus e to the x minus 6 equals 0. Who do I want to help me? Sam? Looks like you want to help me. Or William? Let's go William. Do it. I think I'll Sam too much.
Well, I don't know what to tell you, Professor. I can't hold on.
You want help from Sam?
Yeah.
Sam, what would you do?
Well, now we have like same exponents in two, so we can put 2x over x.
Oh, no, it can't do that.
Okay,
Well, could you add maybe the negatives and? put
so
them on
just
the
pass
other
that
side?
6 for now.
We can't add the negatives because they're different
Oh,
So just
exponents.
pass that 6 to the other side. for
Okay,
now.
here, so we're out of time, so I'm going to hurry on this one. Here's what I'm going to recommend. You're going to do u substitution. I'm going to let u equal e to the x. Okay? And therefore, u squared equals what? E to the 2x. Okay, so then this becomes u squared right here. So this becomes u squared minus u minus 6 equals 0, which is easily factorable, right? Factors into u, 3, 2, minus plus, right? Equals 0. Now I'm going to substitute back, and this becomes e to the x plus 2 times e to the x minus 3 equals 0. Now, if you're really good, you can go from here to here without the u substitution. Most of you probably aren't that quick. That's why I showed you the u substitution, okay? But you could do that if you wanted to, okay? Now, all I have to do is set each factor equal to 0. E to the x equals negative 2 or e to the x equals 3. Now, is there any power I can raise to get a negative number? No. So there, that one doesn't work. Okay? But in this case, how do I solve that? We take the natural log of both sides, pull the x out front, and I'm going to get x equals the log ln of 3. And that's the correct answer. Okay? If you want to check your answer really quick, e to the 2 times the ln of 3 minus e to the ln of 3 minus 6 equals 0. Okay? So I could pull this up here, and that becomes e to the ln of 9, right? So 9 minus 3 minus 6 does equal 0. Not the easiest thing to check, but that is correct. Okay? So your correct answer is x equals the ln of 3. Okay? All right. So as far as homework, we didn't do any logarithmic equations. We'll save those for tomorrow. So as I'm looking here really quickly, okay, up through 48. That's good. Okay? So we'll do up through 48 for tomorrow's quiz. See y'all tomorrow.
Yeah.
And the next test is